Alright, this is a video on the continuation of the problems from section 2.1. So both of my classes got to different places, so you might see an overlap in something we did in class or not, but I'm going to cover all the problems that were skipped in both classes for everyone. So we're going to start with part D on 2.1. This is the first example. And we have this problem where we have a binomial squared plus 3 equals another binomial squared. You have to be careful with binomials, and since there's a plus sign, we need to really write this twice because that's what it means to square, and then we will distribute or FOIL that out. And then we have x minus 2 is also squared, so we'll write it twice. So we're going to do x times x, which is x squared, x times 5, which is 5x, 5 times x, which is 5x, and 5 times 5, which is 25. Bring down the plus 3. Equals x times x is x squared, x times negative 2 is negative 2x, negative 2 times x is negative 2x, and negative 2 times negative 2 is positive 4. Combining like terms on the left, we'll get x squared plus 10x plus 28 equals x squared. Combine the like terms over here, we'll get minus 4x and then plus 4. Now notice all the problems we've been dealing with in 2.1 have been x to the first power. This one looks a little strange because we have these x squareds, but as soon as you go to move the x squareds to be on the same side together, because they're both positive 1, when you subtract, they're both going to cancel out. So this will just be 10x plus 28 equals negative 4x plus 4. We need to get the x's on the same side, so I'm going to do the opposite of negative 4x and add it. So that would give me 14x plus 28 equals 4. To get the x by itself, we need to move the 28 over. So we have 14x equals 4 minus 28 would be negative 24. And then divide both sides by 14. Now that is a refraction, and we leave it as a fraction, but we reduce it. So divide them both by 2, you get negative 12 over 7. We did part E in class, so let's look at part F. Now part F has u is what we're solving for, and it's in the denominator. So we need to first factor all the denominators. So this one's already factored. This is 2 perfect squares, so that's a 2u plus 3 and a 2u minus 3. And this one's already factored. So it looks like our common denominator is going to be 2u plus 3 and 2u minus 3. Because that is going to be something that could possibly turn into a 0, we do have, remember, restricted domains. Restricted domain means there are certain values on the number line that are not allowed to be solutions. So we set both of those factors not equal to 0 because we don't want them to equal to 0. And then we solve for the u. So in this one, this would be negative 3 and then divide by u, or by 2, sorry. That'd be negative 3 halves. This one we would add 3 and then divide by 2. So we do not want our final answer to be negative 3 halves or positive 3 halves because that means our original fractions would have been undefined. We would have been dividing by 0. Your next step in this type of problem is to remember, try to clear out the fractions. Since we have an equal sign, that is allowed. So we're going to take this and we're going to take our LCD of 2u plus 3, 2u minus 3, and we're going to multiply it by each fraction and each piece of this equation. So times the first fraction, and then plus 2u plus 3, 2u minus 3, times the second fraction, and I'll go ahead and leave that bottom in factored form. 2u plus 3, 2u minus 3. Trying to write small so I don't run out of room. And then equals the LCD, 2u plus 3, 2u minus 3, times the final fraction, which is 1 over 2u plus 3, just barely. Okay, in the first fraction, the 2u minus 3's are going to cancel, and you're left with the 4 in the numerator and the 2u plus 3. In the second group, all of the fraction part's going to cancel out with the LCD, so we're just left with a positive 10. And then in the last one, the 2u plus 3's are gone, so it's equal to 1, that's the numerator, times 2u minus 3. I always suggest writing this first and then distributing. So this would be 8u plus 12 plus 10 equals 2u minus 3. Combine like terms on the left side. That would be a positive 22. Subtract the 2u over to be with the 8u. That gives me 6u. Subtract the 22 over to get it away from u. So now I have 6u equals negative 25, and divide both sides by 6. Now, 25 and 6 have nothing in common, and 25 over 6, negative 25 over 6 is not either one of my restrictions. So as long as it's not one of those restrictions and we haven't made any arithmetic errors, this should be the correct answer. Okay, let's look at h. So we're going to factor our denominator here. Very similar, except we're using x's this time. This one would be 2x plus 3 and 2x minus 3. So we have our LCD again is going to be 2x plus 3, 2x minus 3. Those are exactly the same ones we just had, but with x's, and we had u's a minute ago. So the restricted domain, I'm not going to have to redo these again. It's just x cannot equal negative 3/2 or 3/2. Same ones as before. So when we go to multiply or clear the fractions out here, we write our LCD next to each fraction. So times the first fraction. And even if we didn't have a fraction, any term in this equation must be multiplied by the LCD. All right, so we've written it all the way across. So in the first one, the 2x plus 3s are going to cancel. That leaves me with a 2 and a 2x minus 3. In the second one, the 2x minus 3s are going to cancel. I'm left with a plus 4 and a 2x plus 3. In the last side, the 2x minus 3 and 2x plus 3 both cancel, so we're left with the numerator of 5x plus 6. We distribute, so this would be 4x minus 6 plus 8x plus 12 equals 5x plus 6. Add like terms, this would be 12x plus 6 equals 5x plus 6. Subtract over the 5x. I'm going to go over here for a second. That would be 7x. Subtract over the 6 to be on the other side, and that would be 0. A lot of students want to say that this is no solution. As long as you still have an x, you have a solution. So if we divide 0 by 7, x is actually the number 0. And since that's not negative 3/2 or 3/2, we're okay. So it is possible for 0 to be the solution of your equation. Okay, let's look at my last one here. On this part, we'll still have those literal equations to talk about. So my LCD, it looks like this also factors as perfect squares. That's a 2x plus 5 and a 2x minus 5. So 2x plus 5 and 2x minus 5. And then our restricted values, or restricted domain, RD, is that x cannot equal, and you get to a point, so I'm not going to go through all the grueling details on this equation, just kind of show you that once you've done this a bunch of times, you start noticing patterns. So when you're trying to solve these for the restricted values, you think about moving this number over and dividing by this one. So if I move that positive 5 over, it becomes negative 5, and then I'm going to be dividing by 2. If I move a negative 5 over, I would add it and then divide it by 2. So negative 5/2 and 5/2 are the restricted values. So another thing I'm not going to show you is I'm not going to actually show you putting the LCD in front of each of these pieces, because here's the pattern that's developed. Whatever we have in the bottom is going to be missing because it's going to cancel out, and we times the numerator by what's left of the LCD. So since the 2x plus 5s would cancel, this would be a 2 times a 2x minus 5. Plus, in the second one, the 2x minus 5s would cancel, so it would be 3 times 2x plus 5. And then since everything would cancel in the last one, it would just be 10x plus 5. Now, obviously, if you're not comfortable with that, write it all out, show all of the steps. But this is kind of a shortcut that most people adapt to. So 2 times 2x is 4x. 2 times negative 5 is negative 10, plus the 6x plus 15 equals 10x plus 5. Combine like terms, we get 10x plus 5 equals 10x plus 5. This is identical on the same side, which means this is an identity. We defined that in class. An identity means that when you go to solve it, the x's cancel out and you just get 5 equals 5, which is true. That means all real numbers are possible solutions, except we have a problem. We had a fraction to begin with, so we have to say it's all real numbers except -5/2 and 5/2. So that would be our solution. It's every number on the number line except those two. There are going to be other ways to write that. You could write r, which is, this is the real numbers, this double-backed r, minus, and then you could just say there's a group of numbers that we don't use, -5/2, comma, 5/2. So this is actually a more professional way of writing it, but you can write it as a sentence as well. Okay, so we had a few literal equations left. So this one is that we're trying to solve for I, so think of this as being r over 1. We can cross multiply. So this would be ri equals just v, because v times 1 is v, and then to get I by itself, we would divide by r. So I is v over r. For this one, we're trying to get the r by itself, so this is the only term with r, so we just need to get everything else away. So I would subtract over that p first, and then this is all connected by times, so we can actually divide by p and t to get r by itself. So this says that r equals a minus p over p and then lowercase t. Remember, they are case sensitive on WebAssign. And then for this one, we want the h's. Now notice I have two h's, and not only do I have them, they're both in a parentheses. So we need to distribute that 2 first. The next rule is that we want to get all of the h's on one side. They already are, but there's this other piece that's also over here. So we want to move that 2lw over. So we're going to subtract it, so that the only thing on the right side is stuff with h in it. So now the h is on this side right here, and it's right here as well. We can pull that out as a greatest common factor. So this would be h, and I know you can pull out a 2, but you don't want to because we're trying to get h by itself, not the 2's. So this is 2w plus 2l, and then we can finally divide both sides by that parentheses to be done. So h is going to equal s minus 2lw, all divided by 2w plus 2l. Do not try to cancel any of this stuff because these are binomials and they don't match exactly, so you can't reduce it. And then the final one is this lovely creature. The first thing I would probably do is just distribute this p. I know we're solving for q, but it's hard to solve for something when there's distributive properties going on. So this would be q plus p times 1 is p, and then minus pq. And then I would think of this as cross multiplying. So we're going to multiply s times this trinomial that was in the bottom here, and then p times 1 is just p. So this would be, and we do need to distribute this because the thing we're solving for is stuck inside the parentheses. So this is going to be sq. Give it just a second, it froze. There we go. So this is going to be sq plus sp minus spq equals p. The two that have the q are the first term and the third term. So we want to leave these on this side. We want to move the sp over. So I have sq minus spq equals p, and this was a positive sp, so when I move it over, it'll be minus sp. Now I want to pull the q out, because remember, that's the one we're trying to solve for. And do not turn that into 0. That's an s and an sp. Those are different creatures. So to finish this off, we divide by the parentheses. So this is p minus sp over s minus sp. You could try to see if something would factor out on top and bottom. Like I could pull a p out of the top just to show you. That would be 1 minus s. I could pull an s out of the bottom. That would be 1 minus p. That's also an equivalent answer. but it doesn't cause any cancellation. So this is not a match, so, and neither is this. So it doesn't really help us, but you could do that. And that's the end of this video.